says a rectangle has one vertex in quadrant 1, okay, on the graph of 16. Okay, I'm going to sketch that quickly, literally on it, 16. And I hope you remember, it's basically the parent function that's concave down but shift up 16.
Okay.
So it looks something like that, and you got one on the other side, but you don't need to worry about it because you're only looking at the first quadrant. Okay, and another at the origin. Okay, okay, fine. So what is this saying is that there is a particular point on this curve in the first quadrant somewhere here. I'm making this up, like wherever, and another one at the origin. Okay, so it says that one vertex it's on this particular curve in the first quadrant, another at the origin, the vertex. Okay, all right, and then another one on the positive x-axis. So another one on the positive x-axis. So here, let me see, somewhere right there. But I'll go ahead and pick all four, and another on the positive y-axis. Okay. Okie doke. So it looks like this. I can tell already. So well, something like it. It looks something like this. See it right there? There it is. There's your rectangle.
Yeah.
It could be a little shorter, a little longer. It depends on it depends if my drawing is accurate or not. So that's it right there. So there's a box that squeezed in. So it looks just like it. So fine. So express the area of a rectangle as a function of x. Okay. So this will be x. Okay. This will be x. And the y you will be using will be pretty much this curve right here. That's all. So you're basically looking at this and this right here. If you think about it, the y will be, you don't care for this because it's automatically be the same y on the y-axis. You get it? Because the curve, if you go up a little bit, it will be pretty much co-aligned with the y-axis there. So it's automatic. So it's easy. So basically it's going to be x times the y value, but you have to do it in terms of x. So therefore it's going to be 16 minus x squared, just like that. Done. You get that? Let me be neat here. It looks weird, like writing 16 minus x squared. So this is your y, x times y.
Okay.
That's it. You could distribute. I never do that, but I think I should do one. I always remember the last one. Maybe you should have foiled that last one, the foil it, But here it is, cubed. So a of x, so it's 16x minus x to the third power. Okay. B, find the largest area. Find the largest area that can be enclosed by the rectangle. Now, this required calculus, by the way. However, let me ask you. Yeah, because this is it is a cubed function. You don't have like, what do you call it? Like like a parabola function, not a cube. This is the totality. The totality of this area function is the cubic function. Had it been a quadratic, you would use a vertex formula, like the highest point. So let me see. So what did your teacher say about this here? You're allowed to use graphing calculator because that will be the most suitable. So okay, let me show it to you. Yeah, because you don't use the calculus concept just yet, but there is a way without having to graph it. So let me graph this function right here in the graphing calculator. So have a look.
Wait, Toss.
Yes.
When you were doing the area formula, I know how you got x for one side, but how do we know that the other side is the equation?
Yeah.
The y.
You can think of it. You know how the y, it's like this side is like the y right there.
Yeah.
This side is the x. So the y will be pretty much on this curve. Get it?
Yeah.
You don't know exact. I mean, the shape looks just like this. I promise. It just depends how accurate you can draw the curve. Does that make sense? Yeah.
Yeah.
Hey, I can't see your face. I assume you have it
I didn't
yeah.
even. No, I didn't even notice.
Yes.
Right
Yeah.
here. I didn't notice.
Okay, so you could imagine, look, you could even have it here. Watch. It might be the biggest. You see it? It might be the big the biggest area. I don't know that.
Yeah.
You see that? The math will tell
Yeah.
you. The math will tell you in a second. I'm going to show it to you right now. When I graph it, it will tell. You can see it in the graph. So that's what I mean. The y will always be on this side of the curve. Get it? Like,
Yeah,
yeah, you
but
can
how
see
do
it
we
right
know
there.
when we're making the equation? Like we find the area, so it's the base times the height. And how do we know that the height is 16 minus x squared? Like when you wrote the equation.
Okay, because okay, you do know it's length times or base times
With
height, right? If you're
yeah,
standing it up, base times height. But the height, you have no other. You don't have any other value other than that y. How about that?
so you just put it
Yeah,
in.
you
All
use
right,
it.
yeah,
Yeah. So this is something
okay,
that you probably get used to eventually. There'll be another problem that goes from this to that point. Like I'm talking from the origin, like diagonally. They're going to ask you find the longest length, the x and y coordinate on the curve that will give you the longest length. So this is another variation of this problem. But the only way you can figure that out without calculus is to graph it. Don't worry
okay,
about that yet. I can show you when we have time. But this is one particular variation. It's an area. But there's another one that has to do with the how long the diagonal line can actually reach for a particular quadratic curve. Get it? Like where is the longest line? So like could it be here? Could it be here? This is the shortest one right there. The longer one may be right there. Something like that. But you can get the actual x comma y coordinate by using calculus or graphing it. So this is another type of variation. It's not about area. It's about the distance, the distant formula. Get it? Like the distance of the line from to the origin. It doesn't have to be to the origin. It could be into another point way over here. So, but okay, I hope that I know I'm off track, but it's related, entirely related to this
yeah.
problem. But let me go ahead and graph this one.
That makes
Yes, yes. So let's graph this here. So, yeah, the only way you can actually solve for the maximum, the largest, it's called maximizing in calculus, the largest area that you can find. You have no other choice other than using calculator at this time until you learn the calculus way. You don't have to graph it. You don't have to use graphing calculator if you use calculus. So you have to wait on that a little bit. So here it is. Let me graph it. So here it is. So let me double check, making sure that I put that in. Okay, that's the right curve. Okay. So here it is. The only way you can do is that you go and you calculate. You do left bound, right bound. It will give you the max. Remember
yeah.
that? Yeah. So here it is. Now you right now you do get the both values. The a value is your y value in the graphing calculator. So I'll go ahead and put a y here equals a of x. So if you look at the graph, which is just disappeared, dude. Come on. So if you look at the graph right now, your maximum, it says largest area A. So the only answer would be the y value,
Do
a
we
of
need to
x.
do we need to write like the largest area is this number at like the x?
Sure, you can write that, or you can write a equals just like that because
Yeah.
you teach it, yeah, because the notation, you can do a of x, but I'll write just a because I don't want it,
Okay.
I don't want your teacher to get confused with the x value, but you could write both of them. Watch. Okay, I'll go ahead and do this. At 24.63, that's the largest area. What is it? 36 or 63?
Yeah.
I said 63, dude, not 36. 63. That's the largest area. You can label largest.
Okay.
And then you can also add on an extra detail at x equals whatever that was.
Yeah.
Sometime you have to do that 2.3 or 2.31. And I did two decimal places around it to two decimal. There you go. This is the largest area. Done. If you want the unit, you can write unit squared. And there's no centimeters. There's nothing, I believe, right? Yeah, you can write unit squared, but your teacher will be fine with that. Okay, number 5. A landscape engineer has 200 feet of border enclosing a rectangular pond. Rectangular pond? Okay, so here's the pond. Let's say this is the pond. And okay, I see. I assume they go all the way around the pond. Let me read carefully. What is the dimension? Yeah, so it's implied that here's a pond and they're making you do the fencing around it. Don't worry about the 3D. I could draw the 3D like the fence. You don't have to worry about it. They just want like, hey, look down on it and how long the fence is, basically. Get it? So here's the pond. So I would call this X. I would call this Y. It doesn't really matter, but this is how this goes. Yeah. What's dimension that will give you the largest pond? Okay, so it's missing one word, largest area. So it's implied area. Do you see it? Yeah,
Yeah.
largest area. Basically, largest pond. This is like grammar stuff, like, hey, it's real life story, whatever, but it's area. So you got two formula to deal with. Area is equals to x times y. I think you see based on our sketch and our own label. So I'll go like, hey, here's the y, here's the x, because x is normally like the horizontal values. So I'll go with that. But then you have more. You do have the 200, the perimeter. Okay, the perimeter is, the formula for the perimeter if you, without the 200 just yet, okay? So it's going to be, based on our drawing, it's going to be 2x plus 2y. Do you agree?
Yes.
All the way around, perimeter. So you could only use this particular formula, perimeter, for now. So 200 will be equals to, because it's implied, border, enclosed. Get it? Rectangular pond. So you have to use the perimeter. So you substitute 200 with, you substitute p with 200 and then go with it like this. So far.
Okay.
Okay, now, yeah, you always start with what you can substitute. So it's going to be the perimeter that you use. But the question is relating to the largest area. Yeah, your teacher missed that word, the word area. So you're going to do is your objective, therefore, should be a of x, just like the last one. Is equals to what? Get it? So to do a of x, you have to actually solve. Right now, you got one. You got a of x equals to x times y, but you don't know what y is. So you're going to solve for it from here. Do you understand?
Okay.
And then it will be in terms of x. So here we go. Subtract both sides by 2x, divide both sides by 2. It will give you your y. Do you
Oh,
agree?
okay.
Yeah.
Yeah.
Subtract both sides by 6. Okay. And then clean that up. It will be 100 minus x. So that goes right in here. So that would be
So the
100.
equation would be a of x is equal to x
Yep.
times 100 minus x.
Yep. And then you could,
Put that into the calculator.
yeah, you can distribute. I'll go ahead and distribute that. So here's your final. Be 100x minus x squared. So it's a parabola upside down once again. Okay, so now you're not done because you're asked to find the dimension. Okay, so easy. Since yeah, so you'll have to use the calculator again. Is that okay?
Yeah.
Yeah, you can't use calculus here once again. So to get you the largest area, you have to look at the graph of the area and then locate the x and the y value. Don't forget your a of x is your y.
Okay.
So here we go. Let's do it quickly. What was that again? 100x minus x squared. Was that it? Yeah. So graph. So here it is. So the largest area will be, again, do left bound, right bound in your calculator. This one, I just basically trace it using my finger. Here it is. The largest area will be, for the y value, okay, it will be 2,500. And you're
Okay.
at x being 50. That's it. So you can say something like A equals 2,500, largest area. at x equals 50. Done. There it is. Not just. Okay. All right. Let's see. Quickly, if we can do this one. All right. A special window, blah, 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 of a rectangle with the semicircle on each side. Okay. To be constructed. Okay. So this one is actually a window. I remember it being a track and field area.
Yeah.
Okay. Constructed outside. Okay. So reading it carefully, a special window in the shape of a rectangle with the semicircles at each end is to be constructed so that the outside dimensions are 100 feet. So I believe you have to make sure that I understood it the same way here. I believe all the way around is 100 feet. Do you agree?
Yeah.
I think. Okay, I think that's how I interpret it. Construction, that the outside dimension is 100 feet. So that's how I see it. Okay, I could be wrong. If that is the case, then you let me know. So then, all right. So the perimeter will be a circle plus a rectangle. I think you agree. So I'm going to call this x and I'm going to call this y. I'm talking about the dashed line being y, the x being from here to here. Agree so far?
Yeah.
So find the dimension of the rectangle that maximizes its area. So it's just they just want the rectangle. Okay, the dimension of the rectangle in the end. Okay, fine. However, I believe when they're saying about the area, they're talking about the area of the whole thing. Do you agree?
Yeah.
I hope. Special window in the shape of rectangle with, right here, with semicircles at each end. So that means the window literally are like glass. The whole thing is like glass right in there, right? Including the art, including the semicircles. Do you agree? I'm pretty
Yeah.
sure. Okay, I think I'm pretty sure. So the perimeter around it is basically the circle and and the rectangle that involve only this side and this side. Let me see. I'll draw it differently. Oops. Shoot. I messed up. I can't. So it's just this top right here. Top two.
Okay.
Is that okay? Okay. So here I'm
Yeah.
going to express it. So perimeter, it's going to be now the radius from here to here is 2y. One half y. Sorry, one half y. You agree? One half y.
Yeah.
The radius. So I'm going to write. I'm going to do the circumference formula. Okay, circumference. You got 2 pi r and pi diameter. So I'm going to tell the other student 5 minutes here. Quickly, I can
Yeah.
finish it.
I
No,
have to go soon too. So,
okay, okay,
but I understand this.
okay. All right, wait. Let me finish it quickly. So
Yeah.
you know what? We don't need the we don't need the one half. We can literally use the y because I'm going to use the circumference. Don't forget, you're gonna use this one added to that one. Literally, it'll be a circle. Does that make sense? So
Yeah.
it's going to be a
Yeah.
circle. So it's going to be pi times y, okay, plus 2x. There you go. Let me see you agree. Pi times y is plus 2x. So ignore the half y in there. Do you agree? Pi
Yeah.
y, yeah. Pi diameter. Don't forget, we're doing circumference, not the area for the perimeter. So now you can plug in the 100 feet for perimeter. It'll be pi y plus 2x. Okay, now to maximize the area, let's do the area on this side. Area is going to be pi. I'll draw the illustration. This plus the rectangle. Do you agree? So
Yeah.
therefore, the area, not a of x is yet. It'll be pi r squared, which is going to be we do need to half y. So there's no way around that. So it is going to be a half y because of the radius, pi r squared. You get that?
Yeah.
Pi 1/2 y squared, but because that is your radius. This is my y, okay? Pi r squared plus x times y, x times y. Do you agree? That's the
Yeah.
max area. Okay, then.
Okay. That's
So
what.
that's it. All you need to do is solve for y here. It has pi in it. Okay, it has, get it, and plug it in there
Yeah. Yeah. That
and
makes
in
sense
there.
to me. Yeah.
You get that, and clean that up,
Yeah.
and
Yeah.
that would work. Oh, here, let me do this one. I think this is the one that I was telling you earlier. Here we go, dude. Here we go. Number 7. Okay, so the graph looks like it's not a curve this time. It's just a linear that looks like this at 8, 45-degree down. So it's like this, an open dot here. Okay,
Okay.
and it says another at the origin. What is this? A rectangle. Another at the origin right here. So it's something like this. I think it's going to be on the x-axis, yeah, and the y-axis, yeah. So the rectangle is either shape that looks like this or shape that looks like this. You see it? The rectangle.
Okay. Yeah.
Yeah.
Yeah. I get that. Yeah.
Okay, so that means it will be the same as one up here. Do you think you can do it? Yeah, the
Yeah.
y.
I could do that
Yeah,
for sure.
the y will be the line. Get it?
Yeah.
Yeah.
I got that.
Okay, I'll let you do it.